Hello everyone, in this TRICAR tutorial number 46 we will review the point contact transistor invention, starting with the point contact diode, the team who did this invention and how the point contact transistor has been invented at the end of the Second World War, and its first popular application with the first portable transistor radio. Before starting to the point contact transistor invention, I would like again to highlight Russell Ohl. In fact, he did not participate to the transistor invention, but Brettain, one of the transistor inventors, was one of the few people who understand the Russell work. Before starting to the point contact transistor invention, we have to come back with the first rectifier electronic solid-state device, the point contact diode. The first rectifier was found by Ferdinand Braun in 1874. At this time, we have to find the good contact by testing different places on the galena. As in this animation, the first contact does not work, the second one either, then finally the third one works. Why? Because we find a point with a good impurity to do a rectifier. After the semiconductor understanding, they replaced the crystal galena, which is a lead sulfide, by a germanium crystal purified and n-doped. This is the point contact diode. By the way, the diode symbol comes from this point contact diode, where the horizontal line represents the substrate and the triangle represents the wire contact. Again, before to explain how the point contact transistor has been invented, we have to spend some time on the inventors. Shockley worked on the theory of such a device for more than 10 years. While he succeeded in developing the theory, he was unable to construct a working model after 8 years of trying. Bardeen and Brettain were called to handle the engineering and development. Bardeen accepted the generous offer of William Shockley to work at the Bell Lab after the war in 1945. He works with Walter Brettain, another member of Shockley research group. Bardeen and Brettain made a good team, since Bardeen was a skilled theoretician and Brettain was a skilled experimenter who could build anything. Bardeen and Brettain were called to handle engineering and development, which they did in a relatively short time of 2 years, to the consternation of Shockley and its 10-year trials. In December 1947, Bardeen and Brettain did the first point contact transistor. This component had the same amplifier capability as a vacuum tube, but they were smaller, cheaper, more robust and more efficient. As Bell Labs was very concerned that Purdue University would make a similar discovery, the patent was quickly recorded with the name of Bardeen and Brettain, but not Shockley. Shockley was disappointed because he believed he should have received all the credit for this discovery. Following the point contact transistor invention, Shockley worked really hard for the next 2 months to design a new type of transistor called the junction bipolar transistor, which was based on the PN junction discovered by Russell Ohl, and was superior to the point contact transistor, replacing it quickly. Thus, the transistor invention was in a large part Shockley's creation. For this reason, the three shared the Nobel Prize of Physics in 1956. The crystal diode or point contact diode was the only solid-state electronic device, so they started naturally with this component. John Bardeen, the skilled theoretician, told to Bardeen, the skilled experimenter, that he should add a second contact within 50 micrometers of each other. 50 micrometers was the thickness of a sheet of paper, but the finest wire was almost 3 times that width. Instead of bothering with tiny wires, Brettain attached a single strip of gold foil over the point of a plastic triangle. With a razor blade, he sliced through the gold right at the tip of the triangle. Two gold contacts just a hair width apart. The whole triangle was then held over a crystal of germanium with a spring, so that the contact lightly touched the surface. The germanium itself sat on a metal plate attached to a voltage source. Following this mechanical operation, high current pulse is used to fuse the gold wire and diffuse in the germanium with the help of capacitor discharge. This operation was called electrical forming. This machine was the very first semiconductor amplifier, because when a bit of current came through one of the gold contacts, another even stronger current came out from the other contact. This transistor effect was seen the first time in the Bell Labs the December 16, 1947, and for the first time we were able to do an amplification with a solid-state semiconductor. On the left you can see the picture of this point contact transistor. We can recognize the spring pushing the plastic triangle to the semiconductor substrate, the emitter contact on the left and the collector contact on the right side. The semiconductor substrate was a germanium crystal doped N and its base contact. The bipolar symbol with the base emitter and collector came from this initial point contact transistor. You have to note that this transistor looks like a PNP, but it is not, because it does not use PN junction but metal semiconductor junction. The point contact transistors were only manufactured for few years by Western Electric before being superseded by the junction bipolar transistor. On the left, you can see the first point contact transistor with both wires, the emitter and collector, touching the germanium base. The collector was differentiating of the emitter with a 20-degree angle. They are rarely mentioned in modern electronic books, and if they are, usually dismissed as some inferior early aberration. This is unfair to a device which was never fully understood theoretically and which possesses its own unique solid and surface state physics. Following this invention, Bell Labs needed a generic name. Several proposals were semiconductor triode, to do link with the existing triode, surface state triode because of the surface state physics, crystal triode was a reference to the crystal diode. You can note that this name is noted on the first component manufactured by Western Electric. Solid triode shows that it was an equivalent of the triode but in solid state. Fortunately, we avoided the name Iotatron. After those proposals were all considered, transistor, coined by John Pierce, was a clear winner, owing in part of the affinities that Bell engineers had developed for the suffix istor. Point contact transistors has characteristics which reveal how different they were from junction type. When an emitter current flows from the emitter to the base, a collector current 3 times bigger than the emitter current flow from base to collector. So the common base current gain, alpha, well in excess of 1. December 16, 1947 will remain a key date for the electronic industry. This is a day where they shown that it was possible to do an amplification with a solid-state electronic device. Even if this first component has been replaced quickly by the bipolar transistor, it allowed to build the first portable transistor radio using 4 point contact transistors, who popularized for a wide audience the name of transistor. I want to thank you for your attention. On my next series car tutorial number 47, we will talk about the majority carriers in a PN junction. So see you soon and stay tuned.